reefs are one of the most spectacular and diverse marine ecosystems on the planet. They support hundreds of thousands of species, many of which are undescribed by science, and they're renowned for their beauty and biological diversity and high productivity. On top of that, coral reefs support this thriving ecotourism industry worth billions of dollars. However, reefs are declining worldwide and face an uncertain future, mainly due to CO2-driven changes in ocean temperature, but also due to a range of other human impacts. What we currently know is that coral are very sensitive to changes in temperature, but what we don't know is how the temperature response of coral varies between different locations, species, and under natural seasonal conditions. This is really highlighting the importance of field data to better understand the growth response of coral in the natural environment. I started my PhD about 2 years ago, and we've been collecting coral growth data for a range of environments and different reefs along most of the WA coastline. So we've spent a lot of time driving up and down the 2,000 kilometre stretch between Bremer Bay in the south and Ningaloo all the way up in the north. We're looking at coral calcification, which is essentially the calcium carbonate creation of coral skeletons that essentially build these entire reef formations. What we do is we take corals and we glue them onto tiles and secure them onto the seafloor so that we can grow them over time in their natural environment. Every few months we go back to the same spot. We take the corals out of the water and weigh them to measure how much their skeletons have grown over time. We also look at the changes in the environmental conditions that the coral are growing in. So this means taking continuous measurements of important factors like temperature, light, and the carbonate chemistry of the seawater. What we're finding is that the corals don't necessarily always respond in the same way that they would in other places around the world. And so we're going to try and find out why that is, and hopefully this will help to better predict how coral in Western Australia might respond to future changes in climate.